At the end of lesson 5, we had just completed running this particular model specification. And so, generally speaking, if we go back through our report that we started not long ago, we should have almost everything that we need to do this particular assignment. I'm going to show you a couple things as far as plots go. But in doing the assumption write-up that we are going to do, we're just going to need the descriptive statistics. And so we started with that all the way up here, 20,653. So that's the table that we're going to use for our for the dependent variable. See 0, 1. You can explain that there's variance on the independent variable, etc. In terms of one of those other assumptions that we need to do, we need to run some quick correlations. So before I get to creating the plots on the probabilities, we're going to run the correlations really quick and just make sure that we don't have any problems with our model. So let's just do our descriptive statistics, or actually let's do correlates bivariate. And let's go down here and just pick up all of our independent variables that we used. So we used FCNR. We didn't do we didn't do EMS. We did that one. We did that one. We even did systems. We just didn't do assistance and IE in those. And so let's run the Pearson correlation coefficients for those 5 variables. Click OK, and let's take a look. Again, when you're putting your model together, forget about all this stuff up here. One side of the diagonal is the same as the other side of the diagonal, so just kind of start here, and these are 1.00 all the way across. But let's look and see if we've got anything high here. We don't really. These are all in the teens, essentially. The highest one, no, we don't have anything here. So these are all good in terms of correlation, that correlation assumption. For the heteroscedasticity assumption, I may have you do a plot for that, but a lot of times the residuals look weird coming out of the logit, and they're just not the same as OLS, because we don't have that real strong homoscedasticity assumption that we do in OLS. We may do something with it, but before we do anything, I want you to get an idea of what the model just did. And to do that, we're going to run a plot that essentially shows you what the model did. So before we do anything, we need to create an ID variable. And so to do that, we need to sort these and then create the ID variable. So let's sort cases, and we're going to sort them on PRE, that predicted value, and we're going to sort from the lowest predicted value to the highest predicted value. Okay. All right. After we do that, put it at 0.0008 to 0.20. Let's go down and look at that. That's actually important. Let's go down and look at what the highest value was. 0.73 was the highest one, but you notice where we used that 0.05 cutoff value. Look at where that is. That's really high, right? So it just shows you how, in the big picture scheme of things, this is a pretty, we had a pretty safe sample here, right? But we use the cutoff values here, and that makes sense. Let's look at how we're going to present this. And to present it, we need to create a sequence measure that varies from 1 all the way to 20,653. There's a real simple way to do that. So let me just show you. Transform compute variable. I'm going to call this ID. So we'll just call it ID. And the best way to get there is just click on all, and then it'll just do case number, right? And so what it'll do is whatever order it's in, if it's a valid case, it'll give it a number. And so we sorted it already, and it should run from 1 to 20,653 and create a variable ID. Okay. So we did that. See what we did? 20,653 in here. So we're all good there. So we're going to be using some of these variables. So let's just make all these zeros again. These are really small variables, so we'll keep them at 5, and we'll make this one 0. Okay, good. Now, what we're going to do is we're going to create a scatter plot, and we're going to show not only the original dependent variable, the variance on that measure, but we're going to show the predicted probability for each of those observations. And it'll create, if we had a really good fit for a logit model, it would create the full sigmoidal functional form. In this case, it doesn't, and so that's important in itself. It tells us that while the logit model is working, it seems like it's rejecting the null, and the parameters look about right. The model itself is probably not the best functional fit for the question we're working with. So I'm going to stop here, and then I'll pick that up in just a minute. Okay, so let's create a figure that's really good for interpreting what this model just did. And we're going to start that by doing an overlaid scatter plot. Okay, and so we'll go to Graphs, Legacy Dialogs. Let's go down to Scatter dot plot. We have simple scatter, and then we have an overlay scatter plot. And I'm going to use the overlay scatter because I'm going to be interested in two different things. We're going to compare the dependent variable versus the predicted probability. And so we're going to put two different things out there. So the first thing that we're going to do is let's go down here, and our dependent variable, our original one, was firefighter injury. So let's click that over, and we're going to plot that versus that ID measure that we just created, right? That one from 1 to 20,653. So we're going to put firefighter injury, the zeros and ones, and you'll see what that does in just a minute. The other thing that we're going to do is we're going to do the same thing, but we're going to include the predicted probabilities. All right, so let's do predicted probabilities, and then let's do ID as well. Okay, that's pretty much what we need to do. Let's click on OK, and let's let that thing run. It's kind of got a lot of observations, so it takes a while for the graph. All right, good. And so you see what this did? What it shows is this up here is the number of events with a firefighter injury, and see how it's kind of loose and dispersed here, but then it gets really tight here. That's where the likelihood of an injury really gets high, right? And it's like at that 20, at that 5% and above range, right? So if we had a really narrowly divided logit, right, where the end result was not 0.5%, was not 5%. Cutoff, it was a 50-50 cutoff. What we would get is we would get a series of observations that would start like this, and then they would go up, and then they would fit back here, and then they would approach asymptotically. Right? So what this plot tells us is, this is not the best particular fit, because while it's kind of doing what we want it to do, it's identifying these, right? We're doing it at the very tail end. We don't get this full logistic kind of functional form that we would in another estimate. So this is valuable in that it shows us essentially what the model's doing and whether the functional form maps up to a logit specification or not. Okay, so I started editing this particular plot, but it's going to take a little while, so I'm going to stop the YouTube video here and then pick up, and we'll just start. We'll do a whole YouTube video on how to spec out this plot.